Okay, so suppose we are the platform designers that want to realize a new Mashup platform for their specific domain. So first of all, we need to interact with this interface. This is a very simple interface that allows developers, so platform designers rather, to specify what are the features that they need to be supported in their platforms based on the specific requirements of their domain. So what they should do is just selecting a set of features they want to be supported and generate the platform. Very, very simple. So clearly, how to select these features depends on the analysis they already did during the domain domain analysis and formalization. But after this step, after this analysis that must be done anyway, their job is actually simple, and we will see what this means. So in our case, we want to support data components implemented as REST or SOAP services, service components of type request response one way and notification, again, for example, implemented as REST or SOAP. And we also want UI components to graphically show some results of our computations, of our mashups. Then we want manual inputs to be supported, configuration parameters. We specify that we want maximum one operation for each component and no maximum output or input parameters. Then we need to specify the main paradigm for the compositions, and we set data flow as main paradigm. And we also say that we want to support reference passing mode. This is a feature that enables the processing of highly data intensive mashups that cannot be supported by many tools, because processing them requires a lot of resources, of time, basically. But using a reference passing mode, this is possible. And finally, we say that we want user interfaces because we have UI components and we want to render them on a single page. And that's it. Okay, so first, before generating this, the platform, as you can see, we cannot now, we need to check if there are, if the constraints that exist among these features are satisfied. This means that we have incompatibilities or dependencies among some features, so we must check if the platform coming out from this selection is meaningful, is sensible, and so if this selection is valid. So we need to check. Okay, very good. We check. Just to give an example, if we select data flow, the data passing is managed by the data flow connectors, and it's meaningless and indeed would turn into ambiguous semantics if we select also the blackboard approach, so using global variables to pass data. In fact, if we check this, the selection is not valid. Okay, so let's check again. Okay, we are done. We can generate our platform. Very, very easy. Okay, platform has been created. As we have seen, this selection of features works at a conceptual level. So developers actually can forget about all the lower level details, implementation details, design choices, architectural choices, and so on, and just focus about the core requirements of their domain. This is a very important aspect of our approach. This also implies that we remove all the needed expertise that would be needed to develop a mashup platform from scratch, and we should have a lot of expertise in terms of mashup tools, in terms of implementation of web-based systems and so on. And on the other side, as you can see, in few minutes, we created our platform that we will see how it looks like. But this means that there is almost zero effort for the development of the platform. That means very low costs, and that means fostering the usage of this kind of technology, clearly. Okay, so we generated all the platform. This platform includes these files that are the language and so on, and the tools that are the runtime tool, the runtime engine, and the Mashup editor. So let's start from the Mashup editor. We need to pass to the Mashup editor this URL that identifies the DSM platform that we just created, and that we can open the editor. As you can see here, we have a complete editor that I'll show you in a minute, because at the moment this is empty. We don't have any component here. So first of all, let's register one component. We decided to support components implemented with mainstream technologies, like for example REST services, SOAP services, JavaScript, UI components, and so on. This choice allows developers to reuse all the tools, the know-how in general, tools, expertise they already have, because they work with these technologies already since a lot of time, and also to reuse directly already existing components. In fact, if we have an already existing component, we just need to define a descriptor. For any component, we need to define a descriptor that looks like this. So it's very simple. Here we are stating basic properties of the component, so the name, the type, the binding, that is the implementation used to implement it, and then the interface. So we have an operation in this case that is retrieve publication. This is the Scholar component. We have retrieve publication that has an input, that takes an input researcher and spits out publications. So once we describe the component through descriptors like this, we just need to register the component, uploading the descriptor, an XML file, and saying which is the platform the components will belong to. And let's register. Very good. We register the component, and as you see here, if we reload, we have the component here, the Scopus component. Okay. So clearly now we don't have the time to register all the components we want, so we prepare an already set up platform, that is this one. As you can see here, we have all our components, and these are just only the components belonging to our platform, the very specific components needed in our domain. Then the editor, as you see here, for example, supports the UI. So we have page templates that will host and render our UI components. So as you can see, this editor is already reshaped to support all and only the features that we need and that we selected during the design of the platform. This means that we are removing all the noise produced by other functionalities and components that we don't need in our domain-specific platform. That means improving the usability of the tool. Also, the components, as you can see, are represented based on the definition that, of the properties defined through the features that we have defined during the design of the platform. So let's see a simple example. Let's realize a research evaluation process to compute, for example, the publication per year value of a given researcher. So first of all, we can use the researcher by name component to get our researcher. Oops, sorry. Then we use Scholar to retrieve his publications, and based on this publication we can compute the publication per year impact value here. Finally, we want to show this value, this impact value, on a bar chart. let's connect our components. So here, as you can see, the get researcher operation expects an input that is the name of the researcher we want to look for, but we can just leave this input unconnected to any other component, so that this will represent an input for the entire mashup, for the entire process. Then we use the researcher here to feed the Google Scholar component, and with the publication retrieved by the Scholar component, we feed the compute impact operation. Then the impact value computed here, we want to show it on the bar chart, and we put it on the y-axis. On the x-axis of the chart, we will put the name of the researcher. Okay, and that's it. Now, the last point is requires to specify where to put this, where to render this UI component. So, as I said here, we can select a template to be used to render this component. A template is just, as you can see, this is a template. So it's a standard HTML page, including whatever we need, and including also one or more viewport, so-called viewport, that are just placeholders that will be used to host the UI components of our compositions. So let's select this template, and okay, we say that we want to use the viewport called chart viewport, that is the only one that is here, to render and to host the bar chart component in our page. So at this point, we would save the composition and run it. The editor is not complete. As you see also on the graphical point of view, we need to improve it, and also on the functional side, we need to still support some of the features we presented before. And also the saving is not yet implemented now, so I'll show you what the save action would produce. In particular, for any mashup, when it is saved, we will produce an XML file representing this mashup using the language produced by the platform generation framework. And this is the XML that would be produced in this case. As you see, we have researcher by name, we have the Scholar component, publication per year, and bar chart. So all the components used in the composition, plus the page to be used to render them, and finally simply the data flow, the data passing logic. Okay, so beside this XML definition for the mashup, saving would also produce this page. This page, as you can see, is exactly the page, the template we have selected before. So we take this template and we just extend it, including some code to actually run the composition and interact with the runtime environment. So as we have seen here, we need to provide the name of the researcher we want to look for example, Tom Smith, and run. So let's run this composition. Okay, services has been invoked, and this is the result. Tom Smith has publication per year value equal to 9. Here we can see also the computation. So you see we have invoke the get researcher of the researcher by name component, then the scholar component, publication per year, and finally we plot the chart in the bar chart. Okay, so this is an example of application that we can realize through our domain-specific Mashup platform. Creating other composition is very simple, as we have seen. For example, we can modify this one. Instead of retrieving the publication of a single researcher, we want, for example, to compare all the researchers in this department, in the DISI department, and show their publication per year impact values on the bar chart. So we just replace this component with the DISI, the old component with the DISI researchers component. Sorry. And for the rest, it is the same. Also in this case, saving would produce an XML definition like this, or exactly this, indeed, where we have the only difference is that we use the DISI researcher component instead of the researcher by name, but for the rest, it is exactly the same. So, and also in this case, we are using the same template, so it seems the same, but the fact that we don't need to provide any input to the composition, to the mashup, so we can just run directly. Okay, and these are the results for all the for all the researchers in the DISI department. Clearly, these are just fake names, and they are not the actual researcher in DISI, fortunately. Okay, and here we can see also in this case that we have invoked the DISI researcher component in this case, and then as before the scholar, the publication per year, and bar chart components. Okay, so to this point I've shown you how the runtime works, how the mashup editor works, and we can modify as we like the composition, create new composition, and so on. And we have also seen how we can create a given domain-specific platform for a given set of requirements. Let's suppose now, just to show you the flexibility of our system, that we have different needs. So a different domain with different requirements, or maybe we just have changed idea about the requirements that our platform should have. So in this case, for example, we want to realize, to support data components as before, service components as before, but we don't want any more UI components. So we remove UI components from here, and instead of having data flow, we want to support control flow with split and join constructs, and that's it. We don't have UIs anymore. If we want to pass data, we need to select either data flow or blackboard, but since we have said that we don't want data flow, we will use a blackboard approach using global variables to pass the data among components. Let's check if these constraints are valid. No, there's a problem. Okay, sorry. We didn't select any implementation technology for the service components. As you see, it works indeed. Okay, now we are done. We can generate our new platform. Generation is processed. Very good. We have generated our new platform with the new editor, new runtime environment, and all the documents and the languages that we need in our platform. So, first of all, let's register a component, and we specify that this component belongs to the platform we have just generated. Okay, it's registered, and we can open again the editor to see what it is changed. And here it is, our new editor. Very good. We have the components just registered, and with respect to the editor, we have seen before, it is clear that this editor supports different features. For example, we don't have any UI aspect to be defined. We have global variables that we didn't have before, and also the parallel flows are managed because we are working with control flow and not with data flow anymore. And as you can see, also the components are rendered slightly differently because now the composition must define, so the designer must define separately the control flow. So for example, here from this component, from this operation next, this operation will be invoked, and the data passing separately, so using global variables to pass data from one component to the other. Okay, this is all. So as you have seen, our framework really allows the creation of new platforms, new complete Mashup platforms, including a domain-specific Mashup language, a domain-specific editor, and a domain-specific runtime environment in very, very, very short time. So this implies all the aspects I said before. This really fosters and pushes the adoption of this kind of solution that we think are a valuable contribution to reach end-user development, as we said.